In this section of notes, we're going to look at significance tests again, but just a little bit more about how to format our answers. So, when we use our four-step process, just like we did with our confidence intervals, there's going to be some definite overlap here. So in this case, for the state, the thing that you're going to list is your hypotheses, so your null and your alternative. You're also going to give your significance level, so alpha equals 0.05 or 0.01 or whatever it is, and then define your parameters as well. So you'll say, like in the case that we were working on, something like P equals the true proportion of shots made by this basketball player. For the plan step, you're going to name your procedure and check your conditions. So we've already checked our conditions in a previous section of notes. So that was that you had your random condition, your 10% condition, and your large counts condition. For the name of the procedure, what we're working on right now is called a one sample z-test for P, or a one sample test for proportions. Then when we move on to the do step, that is where you calculate your test statistic and then you find your p-value. So we did that also in the last section of notes. That's just part of your do step. Now you can also use your calculator for the do step, where you can use the calculator command with the one prop z test, and then you also have to write down your computer input and output to replace that do step if you're going to use your calculator. For conclude, you're going to write basically two main things. First, you're going to have the interpretation of your p-value. So that is that assuming sentence. So assuming that the null hypothesis is true, there is a p-value probability of getting a sample statistic of blank, or more or less, or more extreme, depending on whether it was greater than, less than, or not equal to in your alternative. And then you'd say that's purely by chance. And then the second part of your conclusion will be about whether or not you accepted or rejected the null. So that's the other sentence I gave you, like, because the p-value of blank is greater than or less than the alpha value of blank, we either fail to reject the null or we do reject the null, and we either do not have convincing evidence for the alternative or we do have convincing evidence for the alternative. All, of course, using context as well, but that kind of fill in the blank structure is what your conclusion is going to be. Now, very similar to what you've seen before when we were working with z-scores, if you're going to do this by hand and you're going to use table A, remember that your table A only gives you this middle situation where you have a z-score and then shaded below. But also remember that this distribution, this approximately normal distribution, is roughly symmetric. So that means the number that you get for your p-value for that middle one from table A is going to be the same as the one on the left because they are symmetric. And then if you wanted to get the one on the right, you'd have to double whatever you got from table A. Now, of course, if you're using your calculator and you're using the one prop z test, that's just going to be taken care of for you, and you don't need to worry about whether it's the top piece or the bottom piece or if you're doubling it or not. Now, one more connection I want to help you make here is that there is a relationship between a two-sided test or a two-tailed test, or in other words, your alternative hypothesis had a not equal to sign into it, and a confidence interval. And that tells us that if we had rejected the null, then we don't really know what the true proportion is. So the confidence interval actually gives us a little bit more information. So let's look at this example. So in this example, we're making a confidence interval for the proportion of people that said they had never smoked a cigarette in this sample that this student did. And we end up with a confidence interval of 0.522 to 0.678. Now, if we had done a significance test for this, remember we looked at earlier things that were in the interval or not in the interval. So if we had done a significance test for this, where our null hypothesis was something like 0.6, since 0.6 is inside of that interval, then we would have failed to reject the null. But if we had done a significance test, say, where the value was 0.5, that's outside of that interval, so we would have rejected the null. What the interval does is it gives us even more information. So we can tell from the interval whether we would reject or fail to reject the null, but we also get other values that are plausible. So we get a little bit more information from an interval than we do just from a test. Please make sure you try the practice problems for this section before moving on.